English to Sahara Neural Machine Translation. This research is to develop an English to Sahara neural machine translation model that incorporates linguistic knowledge which is part of speech. Here are our research objectives. The first one is to develop an English to Sahara NMT system that outperforms SMT by identifying the best NMT architecture. The second one is to identify the best pre-processing techniques, specifically subword segmentation and pre-trained subword embedding. The third one is to identify the best way to incorporate part of speech knowledge into the NMT system. This diagram shows a high-level view of our methodology. First, we take the input sentence and tokenize it. Then we convert the words in the input sentence into subwords. After that, we transform the subwords into vectors. Then we concatenate each subword vector with its relevant part of speech vector. This final vector is sent as the input to the transformer model. Finally, the transformer generates the translation of our input sentence. For the experiments, we used a dataset created using Sri Lanka official government documents. As the first step of this research, we experimented with two major NMT architectures. The first one is the encoder-decoder architecture with attention, which includes an LSTM. The second one is the transformer architecture, which is the state-of-the-art NMT architecture. Out of these two architectures, transformer performed better for English to Sahara translation. Therefore, this research was built around the transformer architecture. This diagram illustrates the transformer architecture. Transformer contains an encoder and a decoder as shown here. Apart from that, it comes with two new features named as self-attention and positional encoding. This is how the translation happens inside the transformer architecture. The second stage was to improve the benchmark NMT model using pre-processing techniques, specifically subword techniques and word embedding, to find the best pre-processing techniques for English to Sahara NMT. Subword techniques can be used to improve the translation quality of morphologically rich and under-resourced languages by overcoming the out-of-vocabulary and rare word problems. We explored these 5 techniques in our research. Our next pre-processing technique was to explore various word embeddings. Word embedding is a way of representing words on a vector space. We explored 2 types of word embeddings, pre-trained embeddings and PyTorch embeddings. Under pre-trained embeddings, 2 algorithms were explored, which are skipgram and SIBO. As the final stage, we integrated part of speech to the transformer model. Part of speech is a label allocated to each word in a sentence which helps to disambiguate between nouns, adjectives, verbs, adverbs in a sentence. We explored 2 methods of integrating POS information to the transformer. This diagram shows the first method, which adds POS information to the input embedding. In the second method, the model treats POS information as a type of positional information and add them to the transformer's positional encoding unit. Now, let's see a sample demonstration of our models. In this demo we will generate translations for our transformer benchmark model, byte pair encoded model, and finally for the part of speech integrated NMT model. This is the English sentence we are going to translate. First, let's look at the benchmark NMT model. This is the output from our transformer benchmark model. We can see that the out-of-vocabulary words are replaced by the unknown keyword. Next we will look at the byte pair encoded model. We cannot see any unknown keywords because the out-of-vocabulary words are perfectly handled by this model. Finally, we will look at our part-of-speech integrated model. So this is the output from our part-of-speech integrated model. Here, we have listed out all 3 translations we obtained above. We can see that the byte pair encoded model generated a very accurate translation compared to our benchmark model. And part-of-speech model has generated a better translation compared to the byte pair encoded model. All the models were evaluated using Blue metric. This graph illustrates the summary of best results obtained for various models in our research. Thank you for watching.